Hi, this is Mrs. Kidman, and in this video, we are going to be discussing how we can multiply rational expressions. So what we're going to do when we multiply rational expressions is it's kind of like what we did when we simplified, but we are going to multiply this time. So it's kind of got an extra step. So what we're going to do first is we're going to start by factoring everything completely, just like we did before. So factor everything completely in each individual rational expression that we have. After we factored it completely, then what we're going to do is we are going to cancel out anything. Then what we're going to do is we are going to multiply them. So all that does is once we have it multiplied, factored out completely, multiplying just means taking all of the factors of one and setting them right next to the factors of the other. You'll see what that looks like. Then after we've done that, our third step is to cancel. And once we've got things canceled, because these are already factored completely, we will be able to get rid of everything that's in common. And then we have that most simple form. So let's talk about how we'd factor this one completely. So let's take a look here. I'm going to factor this top one out. I've got a 2 times a 2 times a 2 times x times x times x times y over 2 times x times y multiplied by 7 times x times x times x times x times, well, we're going to need to move these up a little bit, times y times y times y, all over, not 4, but 2 times 2 times y. Okay, so do you see how we've factored it completely? This is step 1. Step 2 is to multiply it. So all that it means is we're going to now have 2 times 2 times 2 times x times x times x times y times 7 times x times x times x times x times y times y times y. Okay, so notice how I just took this and smashed it all together on top, and 2x times y times 2 times 2 times y. Okay, so we multiplied it all together, we wrote them all out next to each other, and now the best part is the canceling. So what we're going to do is anything that's on top and on the bottom, we're going to cancel it. So we've got 2, a 2, a 2, a 2, a 2, a 2. So notice 3 2's on top, 3 2's on bottom, all canceled. I've got 1x here, 1x here. I've got a y here, a y here. I've got a y here, a y here, and a y here, and a y here. So I've canceled out everything that's in common between those. Now the last step that we have to do is write out that simplified form. So what is that simplified form going to look like here? Well, the only number that I have left on top is a 7. And then I'm going to count how many x's do I have? 1, 2, 3, 4, 5, 6. So I've got x to the 6th because I have 6 x's, and I've got 1 y left. Now on the bottom, what do we have left? In this case, nothing. So if we have nothing left, that means there's a 1 on the bottom, or this actually simplifies down into 7x to the 6th y. So see how that simplified out all the way. Now, for some people, they're like, do I have to write out every single factor first? Now, you can try to multiply it first, which works with these simple monomial ones. However, when we start multiplying a rational times a rational expression, when one of the rational expressions is a trinomial and the other one is a trinomial, if we're going to multiply them completely before we factor, then what ends up happening is we end up having to use the FOIL method and then factor, which is kind of counterproductive. So I'd rather factor first, then just line up all of those factors next to each other and cross out what's in common. So let's take a look at this next example here, where we're going to do the same thing that we did before. So I'm going to list out all of the factors of that first one, because remember, step 1 is to factor. So let's go ahead and do that. I've got a 3, I've got 5 x's, 3, 4, 5, and I've got 2 y's. And then in the bottom, we've got a 2, a 2, a 2, an x, and a y. Now, one step that you can kind of combine is we can do this factoring and this multiplying all together. So what happens is we can then just take these factors and add them in. So I'm going to do them in a different color for the visual effect. But in green here, I'm going to write all of the factors of this expression. So now we're multiplying by 2 times 3 times x times y times y. And that's all going to be over. 9 is 3 and 3, and then we have 3 x's on the bottom and 1 y. Now in blue is when I'm going to do that third step, which is where we cancel things out. And so in blue here, we're going to cancel. I've got a 3 on the bottom and a 3 on the top. I've got a 2 on the top and a 2 on the bottom. I've got another 3 and another 3. Awesome. Then let's take a look. On the top, I've got an X. On the bottom, I've got an X. On the top, I've got an X. On the bottom, I've got an X. On the top, we've got an X. On the bottom, we've got an X. Top X, bottom X. I've got another X on the top, but no more X's on the bottom. I've got a Y and a Y, a Y, and a Y. Okay, do we see anything else that's in common here? I personally don't. So then we need to do that last and final step, which is where we simplify. So what happens when we simplify here? Well, now we need to see what's left over on top after we got rid of stuff. I have this X, this Y, and this Y. So I've got 2 X's and 2 Y's, which is written as X squared and Y squared. On the bottom here, I'm left with 2 2's and nothing else. So 2 times 2 is 4. So this is the simplified expression after we've multiplied those 2 expressions together. Do you kind of see how it works? Let's take a look at another example. Now, before we were dealing with monomial on top and bottom of our rational expression times another monomial. Now we're dealing with more rational expressions where we have things like binomials, trinomials, fun things like that. So what we want to do is follow those same steps. So step 1 is to factor, just like we did before. So let's factor each of these pieces here. So I'm going to factor this top piece. We can factor out a 3x and we get an x minus 1. And then in the bottom here, we're going to use our x method. And we want 2 numbers that multiply to -5 and add to 4. Well, that's going to be a 5 and a -1. So on the bottom here, I've got an x plus 5 and an x minus 1. Then we're going to multiply that times these 2. Now here on the bottom, 3x is as simplified as that gets, or we can see it as 3 times x. It's kind of up to you. The top here, we're going to factor, and we've got a -20 and a 1, which ends up factoring into a 5 and a -4. So this will break down into an x plus 5 and an x minus 4. Okay, everything here is factored completely. Our next step is to then multiply them, which means putting them all on the same line. So now we've got 3x, or 3 times x minus 1, times x plus 5, times x minus 4. And on the bottom, we've got a x plus 5 times an x minus 1 times a 3 times an x. Now, just like we did before, our third step is to cancel. And so we are going to then cancel out what's in common here. I've got a 3 on top, 3 on bottom, an x and an x minus 1, an x minus 1, an x plus 5, an x plus 5. And what are we left with? That's our fourth step, is to simplify it. After I have canceled out everything that I can, what do we have left? In this case, everything on the bottom canceled and everything on the top canceled except for x minus 4. Isn't that awesome? How multiplying 3x squared minus 3x divided by x squared plus 4x minus 5 times x squared plus x minus 20 over 3x. Like, if you saw this problem, would you have ever guessed that it would simplify down into x minus 4? Never, right? Isn't that so awesome how we can multiply these polynomials together and simplify them that way? Let's take a look at a couple more examples. This is another example in that same form. So we want to make sure that we are following those steps. So remember, step 1 is to factor. And so we want to factor this out as much as we can. So again, we're going to factor on top here. On top, I have a common factor of 2x. And we end up with an x minus 5 on the inside. Remember that 2 and the x are actually separate because there's a greatest common factor of 2 and a common factor of x. And then we're going to divide this bottom. Remember, this bottom is a difference of squares. And so we can actually simplify out into x plus 5 times x minus 5. And then we can multiply that times x plus 3. And on the bottom here, I'm going to factor it out. 2 times x times x. Awesome. So then what we want to do is that second step where we multiply them. And all that that means is we are going to create one long chain with all those. So 2 times x minus 5 times x plus 3 all over x plus 5 times x minus 5 times 2 times x times x. Then our third step, as we know, is to cancel. And so as we go to cancel, we're going to cancel out everything in common. So I've got an x plus 5, not an x plus 5. There's only one of those. I've got an x minus 5 on top and bottom. I've got a 2 on top and bottom, and an x on top and bottom. So then what does that leave us with over here when we do that fourth step of simplifying? Well, I have an x plus 3 on the top divided by an x times an x plus 5. Now, I know you may be looking at that and saying, well, I have an x on top and I have an x on bottom. But remember, we can only cancel things out if they are exactly the same. And exactly the same means that they're added or subtracted with the same numbers. So because I have an x plus 3 on top and no x plus 3s on the bottom, I cannot cancel out that x plus 3. Similarly, because I don't have any just x's being multiplied by anything on the top, we can't cancel out any x's. So this x plus 3 divided by x times x plus 5 is actually our simplest form there. Now we're going to take a look at one last type of rational expressions that we might have to multiply. And what those are going to look like is a rational expression in the form of fraction times just a typical polynomial expression. And how we're going to do that? Well, what we're going to do is remember that anything can be turned into a fraction by putting it over 1. So as soon as we put it over 1, all of a sudden we've just turned it back into those problems that we had before. And we can look at it that way. So what we have here is now we want to run back through our steps. Well, let's go ahead and factor. So let's factor the top and bottom here. So the top, we're going to find two numbers that multiply to negative 12 and add to negative 1. That's going to be negative 4 and 3. So we end up with an x minus 4 and an x plus 3. Then on the bottom here, that's again a difference of squares. And so what we're going to do is we're going to end up with an x plus 4 and an x minus 4. Now, how does this relate to this other one? Well, on top, what we're going to have when we factor this completely, we need to figure out what two numbers multiply to negative 8 and add to 2, which are actually going to be which is actually going to be negative 2 and 4. So on top, we've got an x minus 2 and an x plus 4. But what do we have on the bottom? Well, the factors of 1 are really just 1. And because anything really has a factor of 1, we're just going to kind of leave it there, right? I'm not going to write anything. We know that it's a 1, but there aren't really any factors of 1. So then our next step is to multiply. And when it comes to multiplying, we just combine these all together in one long fraction. So I've got an x minus 4 times an x plus 3 times an x minus 2 times an x plus 4 all over x plus 4 times an x minus 4 times 1, right? But anything times 1 is itself, so we're just going to leave it there. Then we get to our third step, which is to cancel or simplify down into 1 all of those things. So whatever I have on top and whatever I have on bottom, they simplify to 1. So I can get rid of this x plus 4. I can get rid of this x minus 4. So what do we end up getting here? Well, I end up with an x plus 3 times an x minus 2. Now we have two options here. Because we're multiplying, what we're going to do is we actually probably want to expand this out as much as we can. We could leave it here at this x plus 3 times x minus 2, but I'm going to FOIL it out so that we know this is the expression that we have here. So we end up with an x squared minus 2x plus 3x minus 6, or our solution here is going to be x squared plus x minus 6. Okay, so you can see we ended up with two solutions that are equivalent, but that's kind of how we're going to do it. So let's take a look at one last problem like this, and then you can be on your way when it comes to multiplying rational expressions. So let's multiply these two expressions here. So just like we did before, following our 4 steps again, we are going to start by factoring. So let's factor it out. This top, our x is the common factor, so we've got an x minus 1. On the bottom, we want two numbers that multiply to negative 5 and add to positive 4, and that's going to be a 5 and a negative 1. So on the bottom, we've got x plus 5 and x minus 1 times, what does this one factor out to be? Well, we've got, not in a parenthesis, we want to do our x method here. Multiply two numbers to negative 10, add two numbers to 3. Well, that's going to end up being 5 and negative 2. So this is going to be times x plus 5 and x minus 2. And remember, that number on bottom there is just a 1. And anything times 1 is just itself. So then when we go to do our second step here where we multiply them, what we're going to do is we need to combine those together. So we've got our x minus 1, our x plus 5, and our x minus 2. Awesome. And that's going to end up being all over x plus 5 times x minus 1 times 1, but anything times 1 is itself. So we just end up here. We want to do that third step where we cancel out or simplify down into 1, all of those things that are in common. So what's on top that's also on bottom? Well, we've got our x minus 1s. We've also got our x plus 5s. So what do we end up with here? Well, we end up just with an x times an x minus 2. Again, as we mentioned previously, we can leave our answer here, or we can use that distributive property, that was a little bit of a wobbly arrow, to then figure out what that's going to be. As I distribute that, we can also write it as x squared minus 2x. So whatever you consider to be the more simplified form is up to you, but that is how we can multiply rational expressions. Whether it's a monomial rational expression where it's a monomial on top and monomial on bottom times another one like that, we can do it that way. If we have a polynomial on top and another polynomial on bottom, we're multiplying it by another rational function built up of polynomials. We've gone over those. We've also talked about how we can multiply a rational function built up of polynomials times just another polynomial. So if you have questions, please, please, please reach out. But that is how we can multiply rational expressions. In the next video, we will be discussing how we can how we can divide rational functions as well. And it's going to be very similar to multiplying.